Okay, today we have one of my favorite integrals. This one is absolutely insane. The integral from 0 to infinity of x to the s minus 1, so s is some number here, over e to the x minus 1. Wow, so we have a polynomial term, at least if that's an integer, and an exponential in the denominator. So what on earth is going on here? Well, we're about to find out. So the first thing we're going to do is rewrite this as e to the minus x over 1 minus e to the minus x. Now this 1 on 1 minus e to the x is particularly useful because we can recall the geometric series. 1 on 1 minus u is the sum from k equals 0 to infinity of u to the k, as long as the absolute value of u is less than 1. And we can just check if the absolute value is less than 1. Well, we're integrating from 0 to infinity. So e to the minus x goes from e to the 0, which is 1, to e to the minus infinity, which is 0. So it's clearly going to be less than 1. And that's why we can do this. Now, when we apply this series, we just have a much cleaner integrand. So that's really kind of why I did it. Now we can just rearrange this. We can take the sum outside of the integrand. I always hate when I do this because I never really know what's the actual conditions for doing this. Someone leave it in the comments below. So we can rewrite this as minus k plus 1x, and now we want to deal with this exponent. K plus 1x is not really a nice exponent, so we're going to let that be u just to make everything cleaner. So if we have u equal k plus 1x, then x is u on k plus 1. So let's see, how do the bounds change? Well, the top bound will be k plus 1 times infinity. And obviously that's going to be infinity because k plus 1 is positive. Bottom bound will become k plus 1 times 0. And now this is just u based on our substitution, and x is u on k plus 1 to the s minus 1. And dx would be, I guess, du on k plus 1. So now we're just going to clean this up. We have u to the s minus 1 over k plus 1 to the s minus 1, and we can combine that into a k plus 1 to the s. Now notice that k plus 1 to the s has nothing to do with u, so we can take it outside of the integral. And now this integral is absolutely famous, surely you know this, but if you don't know it, well, we're about to find out. This is the gamma function evaluated at s. The gamma function is basically a generalization of the factorial function. So this would be s minus 1 factorial if s is an integer, but if it's not an integer, then we still have values for it. It kind of just connects the dots. So this would be gamma of s, and now we have this sum which we can re-index because the first term is going to be 1. So we have k to the s, but from k equals 1 to infinity. And now this is the famous zeta function. This is the zeta function of s. So let's quickly write that in. Zeta, okay, well, I guess it's lowercase. Oh, why does zeta look like that in Google Docs? Okay, we'll roll with it. So this is zeta of s, gamma of s. Absolutely insane result. The integral from 0 to infinity of x to the s minus 1 over e to the x minus 1 is zeta s gamma s. That's actually crazy. So let's look at some nice results. If we take s equals 2, for example, and that's equal to zeta 2 gamma 2. Gamma 2 is, of course, 1 factorial. And zeta of 2 is literally the coolest thing. It's pi squared over 6. Yeah, pi is appearing here as usual. So honestly, this has got to be one of my favorite integrals. Thanks for watching. I'll see you next time.